Hi, this is Ram Reddy, and we are a team of 4 members. And the project we have chosen is implementation of KNN algorithm and testing it on the iris dataset. So, firstly, to explain about the iris dataset and exploring it, here is Aiswarya to explain about that. Aiswarya, can you take over?
Thanks, Sriram. Hi, Aiswarya Marapatla. With the iris dataset, which was taken from the kaggle.com, 3 different iris flowers, and that Tosa, versicolor, and virginica, and it has 150 data points, 50 for each species, and also the dataset contains 4 physical parameters, which are and petal width, and which accurately predict the class of the flower. We believe that these measurements are sufficient to distinguish between the 3 types of iris flowers. And also, we'll also look at the relationship between the characteristics in each bloom and determine how important it is to represent the species characteristics. And about the dataset, and passing over to Rajeev Mukhesh.
This is Rajeev. We have conducted a early exploratory taken, and as we could see, the sample data is, and we have conducted a few data analysis on the questions like how many or what are the names of the columns and how many flowers are present. So we have 50 species, it is a well balanced data set so that the and univariate analysis. In bivariant analysis, we have taken the sepal length and sepal weight to classify the 3 species. As you see, the legend, the 3 species have been indicated with the blue, orange, and green. The setosa and orange indicates the versicolor and the green indicates virginica. As our data is a 4-dimensional data, it is complex to visualize the 4-dimensional data. So as we have chosen the pair takes the combinations of 2 features, plots all the combinations of the features, which efficiently could classify our data points. As we could see, the pair with the petal length and the petal all the 3, and coming univariant analysis. Univariant analysis. We have taken the petal length to determine the species, to classify the species as by performing a univariant analysis. As it is, we don't get the actual presentation of the densities and the histograms. We have performed a probability density functions on each feature. See in the coming slides. And here we have taken the petal length, petal width, sepal length, and sepal width, and 4 different probability density functions for each of the features. We also calculated the mean, variance, and standard deviation for the data we have chosen. Means and standard deviation are indicated in the output. The coming part will be my teammate Sriram.
Thanks, Rajiv. Hi, this is Sriram again. So the part which I have done is regarding the k-nearest neighbor implementation of k-nearest neighbor algorithm. So the way how it works is this algorithm uses a technique called nearest neighbor technique, where let's say a data point has 5 neighbors around it. So it tries to take the the species which has let's say 3 species belongs to setosa and 2 species belongs to versicolor. it takes the verdict of 3 species, like it's setosa. So it classifies that particular data point as setosa. So that's how it goes with this algorithm. So you can set the nearest neighbor count to 5, 3, any of the odd numbers. So yeah, so for now, I've taken the nearest neighbor count as 5. So that I've used sklearn to implement this algorithm within neighbors of 5. So this is what I got. The accuracy, the test accuracy I got is 100%, and the train accuracy I got is 96.7%. So which is pretty much a perfectly fit algorithm, which is not neither an overfitting or underfitting. So that's pretty much good about this algorithm. And as we know, k-nearest neighbors is both a regression and classification algorithm. It works in the either way. So this is a simple algorithm which we have performed on the iris dataset, because as iris data has less number of records, so we have chosen KNN. And the next, all the metrics and the confusion part uh, uh, is deal with Arvind, my team at Arvind. Arvind will take over from here.
Yeah, thank you, Sriram. To know the performance, how much the accuracy and the stat of KNN, we use confusion matrix to detect the performance or algorithm we have used. Like the in confusion matrix, the prediction class and an F1 score. Passing over to the Maanas.
Yep, Arvind. So this is Maanas. So we have performed simple ANOVA test. So ANOVA is performed for the datasets 2 or more categories to analyze the difference between the means. So in our case, we have the reason why we have selected simple ANOVA. So I've used the stats model, and for all the 3 categories, and when we fit into the model, and we get the OLS regression results as the follows. So then we can find the prob of F stats. So this is not our P score test. It came out like 0.004, and our significance level is and I mean the so we will be rejecting the null hypothesis. So in our case, the null hypothesis is there's any difference between these 3. The P score is less than the significance value, we will be rejecting the null hypothesis and we'll accept the alternative hypothesis. And the alternative hypothesis in our case is that there will be a difference between the means of the 3 categories and null hypothesis, and we accept the alternative hypothesis. So that's the result of the ANOVA test. Thank you.
Thank you, Maanas. Thanks a lot.